Hello, my name is Roy Simpson. I am a professor of mathematics from Cosumnes River College in Sacramento, California. This lecture is still kind of a review of intermediate algebra and algebraic expressions specifically. There was a part one to this, and in that part one, it's all about the order of operations. So if you're not sure about the order of operations, please go to part one of this and watch that. Otherwise, in this part two, we're actually going to focus in on algebraic expressions. There's some prerequisites, as with anything in mathematics. There's some things you need to be able to do other than read, write, and understand English. You should be able to be top of your game with arithmetic, be pretty strong with elementary algebra, and you should be pretty good with knowing and how to use the order of operations. And when you deal with algebraic expressions in intermediate algebra versus a previous course, an Algebra 1 course or an elementary algebra course, in general it's in context of word problems. So that's what we're going to do in this lecture, is face a lot of word problems. Before we can do that, we'll go ahead and define a few things. First of all, we'll define what a variable is. A variable is a symbolic representation of an unknown quantity. And common variables that are used are letters like x, y, z. You also see often r's and s's and t's. Sometimes you'll end up dealing with Greek alphabet. Specifically in trigonometry, you'll deal with a theta or an alpha or a beta. Higher level mathematics, you get into stuff like this, gammas and lambdas, so on and so forth. Okay? And anything can really represent a variable, an unknown quantity, even the common happy face. I use that as an unknown quantity very often, just because it's just a familiar, friendly quantity. Now, before defining algebraic expression, I just wanted to kind of give a little history lesson here, if I could. It's known by a lot of students that the letter x is used as a variable very often, and I read around on the internet searched around trying to find out the reason for this. I actually sort of know the reason for this, but I was seeing if anybody else has posted anything on the internet, and I didn't really find anything, but there's actually a story. Now, I cannot say that this is actually true, but I think it might be. There was a mathematician who wrote a text, and in this text, way back when, hundreds of years ago, they used a lot of different letters for variables. X was not just one of them, there was a bunch of them. Well, the problem is that when they took it to the printers, and back then they would use blocks to press. They would dip this letter block in ink and then press it upon paper to make print. Well, the printer basically, as the story goes, the printer asked the mathematician or the logician at the time, listen, I see you got a lot of variables, letters all throughout, and to be very honest with you, stamping all those plus all the letters for the words, we're going to use up a lot of our blocks. Could we just use a letter that's not commonly used in the language? And the mathematician, I can't remember who it was, somebody's going to post this on YouTube and let me know, but the mathematician said, sure, go ahead, I don't care, just change it all to one letter if you want, as long as there's consistency. And they said, okay, well, X is a letter that we don't use very often, so we'll use that one. That is a story that I've heard, and it sounds like it's very realistic. So that is the unfortunate reason why most students think that x is the only variable that exists. That's not true. All right, on we go to algebraic expressions, defining these. There are a lot of definitions that actually exist for algebraic expression, but here's the one I just wrote. It's just a combination of variables and constants, which are numbers, and symbols of operation. So that's all an algebraic expression is. Now, symbols of operation means things that tell us to do something, like plus means add things, minus means subtract things, times means, well, multiply things, and then this little symbol here means divide things. Maybe we have something with this. This means square an object. This means take the square root of an object. So there's a lot of different symbols of operation that we have that tell us to do something. But there's one thing that's not a symbol of operation, and that would be an equal sign. So note, no equal signs. Equal signs are not symbols of operation. It doesn't tell us to do something. It tells us something about an object. It says that 3 is equal to 3. It's saying, it's given a statement. It's either true or false. And so it's not telling us to operate. It's just saying, hey, this is true. So in that way, I just want to be very clear that algebraic expressions are simply anything without an equal sign. Then we have something called algebraic equations that actually do have equal signs, but that's not part of this lecture. Let's go ahead and talk about how to write algebraic expressions from language problems. And again, because this is a review of older material, I'm not, maybe I should give you a couple examples of algebraic expressions first. Algebraic expressions are things like 3xy or 2x minus 1 or the square root of xy plus x squared minus z, something like that, or happy face, that's supposed to be a happy face, minus 3 plus the square root of 17. Those are all expressions. Notice there's no equal signs. All right, they're algebraic expressions. Now, what I want to do is get into the crux of this lecture, which is getting us to do word problems. And so I'm going to introduce a method here. This method is not created by myself. It's actually created by a mathematician by the name of Poya, who wrote a very cool book called How to Solve It in the 20th century. If you have the time, I would recommend reading it. But it all kind of boils down to what I'm about to write. So to write an algebraic expression from some type of language or word problem, first thing you're going to need to do is just read it, obviously, and try to understand the problem. This might involve drawing a picture or just making it some type of mental imagery or something. But this is drawing a picture is often a very good thing. It doesn't always work, but often does, especially in a trigonometry class and future courses. The second thing that we need to do is identify the unknowns, what they're asking us to find. How fast is the car going? Or how long did you sit at your aunt's house? Or something like that. And really important thing to do here is to write the word let and then t. So let t equal the amount of time I spent at my aunt's house. Or let d equal the distance to my friend's house. Or whatever it is. This is what I call the let step. You identify the unknown and let a variable equal that unknown. Very, very, very important step. Also note that you could have more than one unknown. It's very common that you do, so just keep that in mind. The third thing is what most students think is the most difficult part, but really if you do part 2, the third thing is actually a little bit easier for you, is we want to write an algebraic expression for the situation using the unknowns that you labeled in the previous step. So this is the part where you might have to reach into your bag of previous tricks, your old formulas you may have known or something like that. But very, very important step nonetheless. Finally, we are going to use the algebraic expression to answer the given question. So the steps are basically read and understand, possibly draw a picture to help you out, identify the unknown, let your variable equal that, write an algebraic expression involving that variable, and then use that algebraic expression to answer the given question. So let's go ahead and take some examples here. So in this example, which I had typed up previously and I have it in my lecture notes, it's just much easier to copy and paste it. Each citizen of the United States must pay $46,147. I should repeat that. $46,147.78 in order to pay off the current national debt. That's actually, there's a little fib in here. It's each citizen, including children and people who don't work. So it includes everybody in the U.S. But whatever. How much would your family and friends have to pay combined if there are n of your friends? By the way, this source is from www.brillig.com debt clock, and that 7/8/2011 is not part of the web address. Sorry about that. That's just the date that I grabbed it. So let's see. We've read the problem, so I'm just going to put 1. We read the problem. We kind of understand what's going on here, right? We know that they're asking us to write an algebraic expression for how much your friends and family would have to pay if we combine them all up. Okay. The second thing we're going to do is identify the unknown. Well, it turns out they give us that we have n of them, so we're just going to let n equal number of family and friends. I mean, they kind of gave us that, but we'll write it down anyway. Now, a lot of students will actually go a little bit further with this. It's not bad, but they'll also say, "Well, aren't I supposed to know the amount that they're all going to pay together?" So they might say, "Let A equal total amount." I'm totally fine with that. Total amount paid. And notice I'm very terse with this, but it's very important that I label my unknowns. And if I end up writing a few more unknowns than I need, that's okay, because the fact is, when I start thinking about the problem, I will then say, oh well, I didn't need these other unknowns. Now the third thing is that we're going to go ahead and write an algebraic expression involving one or both of these unknowns that will help us with this situation. Well, let's see. If I have n friends and each friend is spending $46,147.78, well, you can pretty much tell that these two numbers are going to multiply, right? If I only had one friend, then altogether they would pay $46,147.78. If I had two, it'd be twice that. If I had 3 friends, it'd be 3 times that. If I have n friends and family, it'd be n times that. So this represents the amount of money that they would have to pay combined. And again, some people would say, well, this equals the amount of money. And actually, that's pretty okay to say that. But technically, they will often just want an expression. So you could write it the first way, or if they're asking just for the expression itself, you could leave off the a equals part and write this, because remember, the expression won't have the equal sign, but this number right here still represents how much. Okay, and I'm going to skip ahead a little bit because I was going to introduce how to evaluate algebraic expressions, but I'm just going to ask it right now. How much would be paid if you have 130 friends and family? Just how much would your friends and family pay altogether? So that means that we're going to let n actually be that 130. So we'll plug that in. That's called evaluating the expression. So we'll plug that into the expression, 46,147.78, and we'll multiply that by 130. So to bring up a handy dandy graphing calculator here, clear it out so that's clean. 46,147.78, and we're multiplying that by 130 to get some number. Was it 599? No, it's more than that. 5,999,000. $211.40. That's the total of 130 of your friends that they would pay. And that's a pretty significant amount. I like problems like this where it kind of throws out a number that just kind of is baffling. Yeah, and by the way, you do know probably around that many people through friends and family, maybe more, maybe slightly less, but at least somewhere around that number. So let's try another example. Suppose you have a car that gets about 20 miles a gallon. How many miles can you drive if your tank holds G gallons of gas and you fill it up 1/3 of the way? Now this is a very complicated problem if you're not ready for it. First thing we need to do is just read and understand what's going on. I definitely have read it. Let's make sure I understand it though. Let's see. So I have a 20-gallon gas, or I'm sorry, I have a car that gets 20 miles per gallon. My car holds G gallons, so they didn't tell me how many gallons of gas that it holds total. It could be 100, it could be 10. But no matter what, we fill it up a third of the way. Okay, and so we just want to know how many miles we need to drive. So I understand that. Next thing, we're going to identify the unknown. Well, need to know how many miles, right? That's what it's saying, how many miles. So I'll let m equal number of miles we can drive and I'm also going to note that they gave me another variable here. G is the number of gallons the tank holds. Now I don't know if I'm going to use all these letters in my expression, but still it would be good to write them down. Now the third thing we need to do here, after we've read and we've understood what's going on, after we've identified some unknowns, one or two, is to write an algebraic expression involving these unknowns for this situation. Now, a lot of students at this point might reach into their bag of tricks and think, oh, d equals RT. You have to ask yourself, did they give you a distance? Well, no, they're asking for a distance, so I guess you could say that it might be this equation, but did they give you how many miles per hour you're going or how many hours you're driving? No. So it's not going to be d equals RT. This is going to be a little more of a challenging problem because this involves what's known as unit analysis. We want to know how many miles that we have that we can drive, right? And they've given us something in miles per gallon. And they've also given us that we have a third of a tank of gas. So we have 1/3 of our total tank. And remember, our total tank is G gallons. So we have 1/3 of those G gallons of gas. So this is gallons. This is all the information they've given us, 20 miles per gallon, and we normally have G gallons, but we have 1/3 of those, so this is what we have. Now, here's where unit analysis comes in, and this is something that should be taught in elementary algebra, but sometimes they don't do this. So if you weren't taught this in elementary algebra, this is a very neat idea. If I want my answer to end up in units, and that's why I'm using these brackets here, we often use brackets for our units. If I want my units to be in miles, and I'm given something in miles per gallon and something else in number of gallons, well, you'll see if I multiply these two objects, the words gallons cancel and I just end with miles. And miles, that's what I want to end up with. Right? I want my units to be miles in the end. So you can use a little bit of unit analysis to say, listen, I need to end up with a certain number of miles. They've given me miles per gallon, and they've told me how many gallons I actually have. I have 1/3 of my total tank of gas. Okay. So this means that I'm going to multiply this quantity here against this quantity there, because the word gallons will cancel, and that'll answer with miles. So I should, if I multiply those two things out, I should get 20, remember the words gallons cancel, times 1/3 times G, and this will be in miles. And now I'll go ahead and just clean this up a little bit. That's 20/3 times G miles. That's a very tough problem. Not a lot of students can do that initially. So I really want you, if there's not a formula that is just blowing you in the face right there, just immediately jumping out at you, that you have to create your own formulas often in mathematics, and the best way to do that is to use the units they've given you. Oh, I see they have miles divided by gallons. Okay, so I'll write that down, miles over gallons. That's what we did here. And they're asking me for the number of miles, so I'll say that should equal some number of miles. Okay. And oh, they've given me that I have gallons. Okay, so let's see. If I put gallons on the left-hand side here, I'll have gallons times miles equals miles over gallons, which is not the same thing. So, but if I put the gallons on the right-hand side, the gallons will cancel, and I'll get miles equals miles. So that must be what it is. I must be multiplying these two objects. Okay, this first object right here, and the second object right here. Takes a lot of practice to do stuff like this, okay? So that's my algebraic expression. Now let me ask something a little more detailed than this even. How many miles can you drive if normally your tank holds a maximum of 15 gallons? Well, remember G is the number of gallons the tank can hold, so we're just going to use this expression here. And instead of G, we'll write in 15. And this is actually not so bad. 3 goes into 15 5 times. So it's 5 times 20, or in other words, 100 miles. So in other words, if your tank holds 15 gallons and you get 20 miles per gallon, but you only filled your tank up to a third of the way, you can go 100 miles. The usefulness of an expression comes in the fact that if you have to deal with somebody coming up to you, if you own a gas station and every minute somebody says, listen, I'm going to fill up my tank a third of the way, I get 20 miles a gallon. But everybody shows up every different minute, they just have different size gas tanks. You could use this expression and say, well, what size is your gas tank? Great. 15 gallons? Okay, so you'll get 100 miles out of that. The next person pulls up and they say, mine's 20 gallon gas tank. And you say, great, you filled it up a third of the way, you can go so many miles. And you just keep plugging it into the expression. That's the power of using an expression. Finally, let's talk about this example here. You want to calculate your average exam score in your current math class. Now, out of 4 exams, your scores are 71, 83, and 87. Assume that these are out of 100 points. But yet, you haven't taken your last exam, so you're kind of like, well, what do I need to get on my last exam? You don't know. But the question is, what is the average of these scores? Well, you should know that the average is equal to sum of scores over number of scores. It's always the sum over the number of items. Okay. So the first thing I'm going to say is I've read it. I read it and I understood it. I know what's going on. I just want to calculate an average. And then that's the first thing. The second thing is to label the unknowns. Well, I kind of tell you what to do. Call this U. So let U equal the unknown test score. You don't even have to be that verbose. You could just say unknown score. And now third thing is to write an expression involving this variable. Well, the expression I've kind of already done right here. You just sum of scores, which would be 71 plus 83 plus 87 plus the unknown divided by the number of scores. There happens to be 4 of them. Of course, this is not actually the best way to write this because if I was your instructor, I would mark you down. You should add up these numbers up here. So that's 160, 170, 241. 241 plus U all over 4. And that would be the average of those scores. And of course, if you know, let's say you know that you take the exam and you get a 30% on your exam, well then if that's the case, you could just say, okay, well then my average is 241 plus 30 over 4, which is 271 over 4, and then you could just reach for a graphing calculator or a regular old calculator and figure out what that is. So I'll just kind of scoot this over here and I'll do that. Turn this sucker on, clear this out. 271 over 4? Just out of curiosity. 67.75%. So there you have it. That's how you would do it if once you found out your score. But this right here would be the official answer for that problem. The next little subtopic here is evaluating expressions, and that essentially means just plugging in values for the unknowns when I give you values or when you're given values. So let's try an example here. So let's go ahead and evaluate y plus 1 divided by 3w squared minus 4 for y equals 3 and w equals a negative 2. The way I've always done this is I put parentheses in where my unknowns are. It's a very good tactic because it keeps you from making stupid mistakes. So in for y, I'm going to plug in 3, and in for w, I'm going to plug in a negative 2. And already I see that using parentheses where the unknowns were helps out, because had I not put parentheses right here, I would have had something that looked like this. And people often get very confused. So putting parentheses there is super important. It makes a huge difference. That's multiplication. Without the parentheses, it's a subtraction. So be very aware that when you're evaluating algebraic expressions, you put parentheses where the variables are and then fill in those parentheses. All right, let's go ahead and do this. So this will be 3 plus 1 up top. Downstairs, following the order of operations, we'll have 3 times negative 2 squared, which is a positive 4. Remember, subtraction is the simplest operation, so we're saving that for last. So 3 times 4 is 12. And then finally, 12 minus 4 is 8. And this would not be a final answer. Your answer is not correct until you reduce that fraction. Good old arithmetic, you should be able to do that. In the next example, we'll just take a look at the quantity t minus k being cubed plus 1 divided by r plus k cubed. Again, we have some object minus another object being cubed plus 1 all over an object plus an object cubed. And I'll fill in these values here. That was a t, so the t value is 5. This was a k, k was 3. This was an r was 10. And finally, this was a k, so k is 3. I see this, the innermost parentheses here upstairs will be 5 minus 3, which is going to be 2. Downstairs, we still have the 10 plus 3 cubed. I could have done some work there, but I chose not to yet. Upstairs, 2 cubed is 8. Downstairs, 10 plus 3 cubed is 27. So this will turn into 9 over 37, and there's actually no way to reduce that. So we're kind of stuck on that. 37 is prime, so you can't really cancel anything out. Now I have 2 last examples, and they're very similar to one another, but they're kind of my favorite examples in this section, because they're very similar to one another, but there's a subtle difference, and they're somewhat realistic. So let's suppose you know a loan officer, her name's Lisa, and for every loan that she closes, in other words, every loan that she sells, essentially, she makes $500 plus a 1.5% commission on the loan amount. So she earns 1.5% of whatever the loan was. Find Lisa's income when she closes a loan for $205,000. Well, the first thing we'll do is read and understand what's going on. I read it, and I definitely understand what's going on. I'm miswriting things, but it's okay. Probably won't be the last time. Second thing we need to do is identify the unknowns. Well, the thing we don't know is her income. So let I equal the income. But there's something else we're missing here. So for every loan she closes, blah, blah, blah. Well, actually, they kind of gave us the amount. So we pretty much are at the point here where we don't need to go any further with variables. But well, I think that's good. All right. So the third step is to write an algebraic expression, although this is actually going to be an equation involving this variable. Let's see. She makes $500. I know that. Plus, right? Because that word plus means plus. A 1.5% commission on the loan amount. That's 0.015. Remember, percents must be written as decimals in mathematics. It's from arithmetic and pre-algebra and elementary algebra. Of the loan amount. Now, normally, I would have maybe back in this step said let L equal loan amount. And so normally I would have an L here, because then I can kind of adjust what the loan amount was. And so I would know that her income would equal 500 plus 1.5% of the loan amount. But in this case, they gave us the loan amount. The loan amount was $205,000. So all I need to do is a little bit of order of operations here. So we have 500 plus 1.5% of $205,000. So her income would be $3,575. It's a pretty nice income. However, now let's go ahead and change the situation. This time, we're having the same kind of situation, but she's going to package her loan with the $500 fee. That is, she's going to charge $500, but will include that $500 in the loan for her client. So let's see what happens if she closes a loan for $205,000 and she packages the loan amount or her fee into the loan amount. So I kind of understand what's going on. I've read it. I sort of understand it, I suppose. Might take me having to describe it to myself. Let's pretend that we don't know the loan amount, just so I can kind of do what I did last example, just to show you. And we'll write an algebraic expression for her income. Now, her income, well, it's based on the $205,000 loan that she just closed. And normally we would get, she would get 1.5% of that. But she's tacking on to that $500. So she gets 1.5% of $205,000 plus the extra 500. So notice the difference between this example and the last example. She's packaging the loan with her $500 fee and then getting the 1.5% on that. And in fact, as I'm reading this, I wrote it a long time ago, she will charge $500, but will also have that $500 included in the loan for her client. I think that's very illegal. That's like charging money twice. So I'll keep it just like this. So we'll just say that she charges $500, but she's going to include that in the package loan. All right. So here we go. This is actually not how she would do it. Okay, but this is kind of an interesting scenario anyway. So that means she gets 1.5% of 205,500, which is equal to $3,082.50. Now, to be honest with you, this would be a silly way for her to do it anyway. Notice that in the previous situation, which was, let's see, previous page, this one right here, she made $35.75. That's because, well, she gets to charge $500 for her services plus the extra 1.5% of whatever the loan amount is, which makes sense. This situation here is just dumb. She's not actually charging $500 for her services at all. She's charging 1.5% of $500. So two totally different situations. She earns a lot less this way if she packages her 500 with the loan. As I'm reading this, I'm not sure how I meant to write it before, but it seems to me that I meant it to be written this way, but because it would be illegal if she charged 500 plus she packaged the loan with $500 fee. So I don't think that's possible. Anyhow, but that's how you evaluate or actually write algebraic expressions for word problems. Please practice that skill. Polya's method of reading and understanding, and then letting an unknown stand for, or letting a variable stand for the unknowns in the situation, and then writing algebraic expressions involving that unknown, and then possibly evaluating that algebraic expression to answer some stated question. That is a theme in most intermediate algebra courses.